So as most of the participants are from non-petroleum engineering background, so I would like to uh, provide all of you an introduction to the oil well production system through some of my slides. As you can see here are total 6 pictures, and these pictures are showing the presence of different oil reservoirs. All over the world, we have 6 different types of natural driving mechanisms from which crude oil is produced. And most commonly found oil well reservoirs are of these 4 types. This first picture is called solution gas drive reservoir. Near to this solution gas drive reservoir, another type of reservoir is present, that is called water drive reservoir. And on extreme right, on top corner, this type of reservoir, it is called gas cap drive reservoir. And the another type of reservoir is called combination drive reservoir. As we know that crude oil is produced from the oil bearing reservoir, and this oil will reside in the oil bearing part of the reservoir. As you can see here in the brown color, these are oil bearing part of the reservoir. Here also you can see presence of oil in the oil bearing reservoir. Here also you can see the presence of oil beneath the gas cap, and in combination drive also you can see the presence of gas in the middle section of the reservoir. The crude oil reside inside this reservoir within the microscopic pore spaces, and this is showing my photograph, thin section photograph that shows how crude oil reside within the pore spaces of the reservoir. The black color represents the crude oil, and this crude oil are in the white spaces, which is called pore spaces, and these pore spaces are interconnected. This is one of the requirements for the crude oil to flow to the producing well. This diagram you can see here, this is called production well. All these are wells, and since they help in the extraction of oil or crude oil flows through these wells, it is called production well. Now coming to the first diagram, that is about the solution gas drive reservoir. In case of solution gas drive reservoir, crude oil will be present in oil bearing reservoir, and there will be no additional external support in form of gas cap drive reservoir or water drive. Only oil bearing zone will be present in that type of reservoir. And in such cases, in the initial stage of crude oil production, reservoir pressure will be very high. The pressure will be above the bubble point pressure of the oil. Therefore, all the gases will be in the solution of oil, and reservoir will have crude oil in liquid phase. As the pressure depletes with cumulative production, gas bubble will start liberating from surface of oil, which were initially in solution of oil. This gas bubble will liberate, as you can see here, these small bubbles. These will liberate from surface of oil, and they will displace the oil towards the producing well. This is the natural driving mechanism for the solution gas type reservoir to produce crude oil. Moving to the next type of reservoir, this is called water drive reservoir. In such type of reservoir, you can see here the presence of oil bearing reservoir. Beneath the oil bearing reservoir, we have 2 different forms of aquifer. This is called aquifer. Aquifer rock is nothing but water bearing rock. So the presence of aquifer you can see here at the edge of the oil bearing reservoir, and here the oil reservoir is completely surrounded by a larger aquifer or water bearing rock. So in this process of crude oil production, what happens, from the aquifer, water will influx into the oil reservoir, and that will help in the displacement of oil with cumulative production, when the oil will be leaving the porous spaces of the reservoir rock to flow into the well. The influx water from the aquifer will maintain the reservoir pressure inside the reservoir. Therefore, pressure can be maintained in this type of reservoir for a very long time of a long period of time and at very high pressure. Therefore, crude oil recovery from this water type reservoir is higher than solution gas type reservoir, because in solution gas type reservoir there is no external force to replace the pressure loss with cumulative production of crude oil. The crude oil recovery from water type reservoir will be higher than solution gas type reservoir. Moving to the next type of reservoir, it is called gas cap type reservoir. In this gas cap type reservoir, you can see here the presence of a gas cap uh, above the oil bearing zone. So with cumulative production, or initially the reservoir pressure will be very high, and inside the reservoir, and crude oil will be flowing to the well at its own pressure. Thereafter, gas cap expansion will help in the maintaining of the reservoir pressure, and crude oil recovery in this case also will be higher than solution gas reservoir, because the drop in reservoir pressure in the oil reservoir due to withdrawal of crude oil or for the production of oil towards the producing well, that will be maintained with the support of expansion of the gas cap or influx of the gas into the oil bearing reservoir. The another common type of reservoir which is found worldwide is the combination type reservoir, and this reservoir represents or it reflects to be an ideal reservoir. An ideal reservoir is one where you will see the presence of oil bearing zone, gas bearing zone, as well as water bearing zone. So in case of combination drive reservoir, you have gas bearing zone, oil bearing zone, as well as your water bearing rock. But the size of the aquifer or the gas cap is not very large to maintain the pressure in the oil reservoir. Therefore, the recovery is not very significant. But whenever pressure is maintained by adopting injection of water into the aquifer from the surface, or gas is injected into the gas cap zone from outside source. Pressure can be maintained at a higher level. So these are in nutshell how crude oil is produced from different oil well reservoirs. Worldwide, we have different oil recovery methods. The recovery methods are classified into three types: primary recovery, secondary recovery, and tertiary recovery. That is as per old classification. As per new classification, oil recovery methods are divided into two types: primary recovery and improved oil recovery. If we discuss the old classification of oil recovery methods, primary recovery method is the method where natural energy of the reservoir will be utilized in the production of crude oil from the reservoir. You have already seen the solution gas drive reservoir, water drive reservoir, gas cap drive reservoir, combination drive reservoir. All these reservoirs have the self potential to flow from the reservoir into the well. But whenever the primary energy, which is the inherent energy of the reservoir, that no longer becomes unable to help in the displacement of crude oil towards the producing well because of pressure depletion with cumulative production of oil, it is required to introduce secondary recovery methods. The secondary recovery methods include injection of gas or water, and or the other method is the water flooding. In primary recovery method also, if the primary energy depletes, but somehow reservoir fluid can flow from the reservoir into the bottom of the well, but further fluid flow. So I was telling about the need to when it is required to introduce secondary recovery methods in oil well production system. So this is required whenever it is anticipated that the inherent energy of the reservoir is not adequate, and that is not helping in the displacement of oil towards the producing well. So we require to maintain the reservoir pressure, because reservoir pressure is the driving force for the crude oil to flow from the subsurface reservoir then through the well and through downstream flow line into the surface facilities. So there are two methods. One is called water injection, where water will be injected into the aquifer, or and for this method, it is required to have a good communication between the aquifer and the oil reservoir, and this is called in technically there should be presence of good particle permeability. And if there is no good connectivity between the aquifer and the oil reservoir, water has to be injected directly into the oil bearing part of the reservoir. As you can see here, water is being injected directly into the oil bearing part because of lack of sufficient connectivity between oil reservoir and the aquifer. So these are different pressure maintenance techniques, because for a well to flow at high pressure conditions, it is required to maintain the reservoir pressure, and the reservoir pressure is maintained under different methods. One is called crystal gas injection. In this process, the gas is injected into the gas cap zone. If gas cap was originally present in the reservoir, this is a good choice, and if it is found that the size of the gas cap was not large, therefore it was not possible initially to maintain the reservoir pressure in the oil bearing part. So gas is injected so that gas can further maintain the pressure. In another method, this is called peripheral flooding. Whenever there is good connectivity between the reservoir and uh, and there is less heterogeneity, in such cases, uh, uh, as a part of the secondary recovery methods, the injection wells injected drilled. So this drilling process is done at the periphery of the field, so that the fluid can flow uniformly towards the producing well. And the third method is the combination method. This is known as pressure maintenance along with the support of gas injection as well as water injection. And fourth one is the water flooding method. If there is no good connectivity between the oil bearing part and the water bearing part, which is called aquifer, in such cases, water has to be injected directly into the oil bearing part of the reservoir for better displacement of oil towards the producing well. So this is a picture at the right side. It is showing the wellhead system, and the fluid from the subsurface will be flowing through the well to reach this wellhead, and from the wellhead further it will be sent through downstream flow lines to surface installations for further separation of crude oil from gas, water, and lots of impurities which will be flowing from the downhole to the surface. This is showing the production system of the well, where you can see there are three significant parts. One is the reservoir part, from where crude oil has to flow. Crude oil has to flow from the reservoir to the bottom of the well, and this part is called inflow performance part. Here, crude oil, not only crude oil, uh, the the time broth time well fluid is used. Well fluid will be flowing from the porous media to the bottom of the well, and from bottom of the well, fluid will be flowing further up the tubing, and this part is known as vertical flow part, and the remaining part is the downstream flow part, and fluid has to flow further from top of the tubing to reach the surface installations. For the fluid to flow from the reservoir to the bottom of the tubing, then from bottom of the tubing to the top of the tubing, then from top of the tubing to the surface installations, pressure differential is required. Pressure must of the reservoir must be higher for the fluid to flow from here to the bottom of the tubing. Again, for fluid to flow further from bottom of the tubing to the top of the tubing, further pressure differential is required. So in that way, pressure differential helps in the movement of the well fluid. Coming to the main topic, flow assurance. So whenever fluid flows from the reservoir to the well, then from the well to the surface installation for final separation of oil, gas, water, and other impurities, so that pure oil can be separated from all other impurities and finally sent to refinery for further processing. So in the entire production system, there are many hindrances that are encountered time to time. So therefore, these hindrances is required to remove. And for ensuring removal of these hindrances, which are mostly solid depositions, these hindrances are required to remove, and the process of analyzing the different hindrances and to ensure that fluid flows economically and smoothly through the entire production system, uh, fluorescence process was initiated, and it has been introduced in the oil and gas system in 1990s, and it was coined by Petrobras. So fluorescence is nothing but it is a discussion of about the solid deposition issues which may take place in the porous reservoir or in the formations. Therefore, it will be giving hindrance for the crude oil to flow, because crude oil will be flowing through interconnected pore spaces, and these solid deposits also develop and take place on those void spaces of or the spaces through which crude oil is otherwise supposed to flow. Therefore, it will provide hindrances for the fluid flow from the reservoir. It can also take place inside of the deposition. Solid deposition may also take place inside of the tubing or inside of the flow line. Therefore, it is required to give assurance so that no flow deposition takes place, and it can be removed with taking up measures, suitable measures for the well for sustainability of the flow. So flow assurance is a relatively new term in oil and gas industry. It refers to ensuring successful and economic flow of hydrocarbon stream from reservoir to the point of sale. So there are different forms of deposits that takes place inside the reservoir, inside the tubing, or inside any flow line. These are the kind of deposits. Scale is inorganic deposits, other organic deposits. Formation of hydrates may take place inside the flow line. Wax paraffin deposition may take place in the formation inside the tubing. Therefore, it will limit the flow of crude oil or flow of well fluid from the reservoir through the tube, through the well, and through downstream flow line to reach the surface installations. So we'll discuss first about the scaling issue. Scaling, this issue is related to water injection process. As we know that in case of secondary recovery process, whenever natural force, natural driving energy is insufficient for the assistance of the fluid to move from the reservoir into the well, and from bottom of the tubing to the top of the tubing, or in the entire production system, it will require to maintain the reservoir pressure, so that reservoir pressure support is given for the fluid to the fluid to flow. And whenever this is done by injecting water into the aquifer or into the oil bearing part, so this aquifer will already having water, and those water are mostly saline water, and they are highly saline water. Similar case will happen in case of oil reservoir also. Hydrocarbon reservoir contains some amount of water, and that water are mostly saline water, and they contain different dissolved salts, like calcium, magnesium, sodium, potassium. So these salts results in different salinity. So whenever the water which will be injected into the reservoir, this water is not compatible with the already present water inside the reservoir. The scaling deposition takes place. So scale is any crystalline deposit resulting from precipitation of mineral compounds present in water, because these minerals will initially in solution of water, but whenever some incompatible water is mixed up with already containing water, So precipitation will develop, and this precipitation, if it is viewed in microscope, it will show the presence of some solid deposits, and these solid deposits become eventually the reason for limiting the crude oil production from formation to the well, and from bottom of the tubing or through the tubing. So these are different oil field minerals which has the potential to give scaling issues. The most common scales which are found in oil production system are calcium carbonate, calcium sulfate, barium sulfate, strontium sulfate, iron compounds, iron sulfate, iron oxide. So these are the list of the different scaling compounds which may deposit in the formation, inside the tubing, or inside any surface installations. So these deposits take place, and this is a relevant issue whenever crude oil is produced under either bottom drive, either water injection process or water flooding processes. So scaling have several negative impacts in oil and gas production system. As you can understand that this scaling deposits is going to plug our production system. It may be going to create some deposition inside the formation, thereby giving hindrance for the fluid, crude oil, well fluid to flow into the well. Or also this deposition may take place in the piping system or within any process equipment. So therefore, it will limit the flow of the oil. Therefore, this scaling deposits is required to remove. So scale deposits can take place in any part. It can take place inside the valves, or scale fines. If their fines are present, they can form emulsions, and finally, it is going to affect the separation process also. So there are different methods, laboratory methods, to find out the kind of deposits but a well may having. So these are some laboratory methods, some physical methods, some chemical methods are carried out in order to find out or identify what type of compositional deposits are present as scale in our reservoir, in our production tubing, in our surface installations. So these are some methods in order to find out or identify the scale deposits, because based on different types of scales, the measures which will be required to contain the scales will be different. And identification of scale is also done by X-ray diffraction method and chemical analysis. Therefore, it is required to avoid this scale deposition occurrence in the entire production system or in oil well production system. How to avoid this scaling deposits? It can be done by various means to avoid commingling incompatible produced water, because it is a kind of issue which is related to water injection process, and because of incompatible mixing of injection water with already present formation water. So if both water is made compatible, then scaling issues can be avoided. Also, seawater and produced water, whenever mix up, then scaling often results. Therefore, it is required to avoid commingling of seawater and produced water. Third one is minimum pressure and temperature changes in areas where scaling would be particularly damaging. So it is required for maintaining the solubility of the scaling generating minerals. Therefore, whenever there is some fluctuation in the pressure and temperature of the well fluid, it often results in scaling issues in case scaling minerals are present and water injection is the process of recovery. Therefore, it is required to maintain to add some scale inhibitors with water, so that this scale inhibitors that does not promote it reduces the extent of the occurrence of scaling. So this scale squeezers may be injected. It may be injected in both vertical wells, horizontal wells, or this scaling inhibitor may be added to fracturing fluids, or it may be mixed up with some propane. So whenever water is a component in the production system, with that water scaling inhibitor somehow should be added to avoid the occurrence of scales. There are different mechanisms for controlling scale depositions uh, because scales, when precipitate, the scaling precipitation will agglomerate by joining one particle with the rest of the particle if they find their nucleating agents. Therefore, it is required to modify the the way scales develop. So scales are classified based on their removal methods. So some scales may be termed as chemically inert scale, some are chemically reactive scales, and uh, some require mechanical methods to fix this issue. Chemically inert scales are those scales which are not the solid, uh, which cannot be dissolved using chemicals, and reactive scales are those uh, which can be dissolved using chemicals. So there are two broad types of scale removal methods. One is mechanical methods, another is chemical method. In case of chemical methods of scaling, like sodium chloride, water is sufficient to dissolve them. And in case of acid soluble scale, like calcium carbonate, iron sulfate, iron sulfide, iron oxide, so acid is required. But this acid cannot come into contact with the scale directly because of quotation of these scaling compounds with hydrocarbons. So in this case, surfactants help in releasing these scaling minerals and in the prevention of or the removal of these scales. Acid insoluble scales or calcium sulfate or gypsum. This type of scales require typical treatment. It is required to first transform this scale behavior uh, the, to be soluble to different chemicals. Therefore, calcium sulfate is treated with chemical solutions to convert them to calcium sulfate, which is an acid soluble compounds. There are certain other chemicals which are expensive, which does not require any conversion methods for scaling to control, like EDTA and DTPA, but they are expensive and they're highly expensive, and therefore they are not widely used. Chemically inert scales are those scales like barium sulfate, strontium sulfate, and this barium sulfate scale on the formation phase of perforation may be removed by mechanical methods because they cannot be dissolved. Therefore, mechanical methods are applied to remove those deposits using different cutters, or sometimes if those deposits takes place inside the perforation by bypassing the perforation in the well is the most preferable method. For preventing scales, there are defined method to inhibit scale precipitation. We can apply inorganic polyphosphates, polyorganic acids, organic phosphates, phosphonates, polymers, and for some scales, it is required to maintain the reservoir pressure. If the reservoir pressure is kept above boiling pressure, or if it is maintained at very high pressure on the and then most of the scaling deposition does not result. So it is required first to identify the cause of the scale, why scalings are formed, what are the composition of the scales, and based on that, we have to find out how to remove them. Whether mechanical method will be suitable or chemical method will be suitable, we have to determine based on their composition. As you can see here, this is a production system. It is showing the reservoir part, well part, and the surface installations. All components have the potential to suffer this scaling deposits issue. Therefore, we have to find out where the scales are forming, what type of scales are present, and what will be the most preferable or suitable methods to contain those issues. Another type of solid deposition is the hydrate formations. So hydrate formation is usually driven by water condensation on the pipe walls when natural gas encounters very low temperature and high pressure conditions, hydrates may form. And whenever these hydrates agglomerates with time, and uh, they can prevent the fluid flow through the flow lines. Therefore, it is required to remove those or treat those hydrates so that this hydrate can be made to flow through the flow line for the sustaining of the fluid flow through the flow lines. So hydrates form thin film along the pipe wall, causing increasing thickness and forming a flow path restriction by reducing the cross-sectional area for flow. So gas hydrates is a crystalline solid, as you can see here. Uh, Suitable gases are required like carbon dioxide, hydrogen sulfide, several low carbon number hydrocarbons. If gases are present in well fluid and they come in contact with the condition of low temperature, so gas molecules become trapped within the case of water molecule, and it is how hydrates form. In order to mitigate hydrate formation issues, what is required inside the tubing or inside the well? So it is required to carry out different measures. One of the common measure is the depressurization method, because for hydrate to form, what is the required conditions? Low temperature is required, high pressure is required. So if the pressure of the water is reduced, because the water will be holding the gas hydrates. Therefore, if the pressure of the water is reduced, hydrate can be dissociated from the from inside of the well, inside of the tubing, inside of the flow lines. So this is the way how hydrate can be mitigated. Another option to mitigate hydrates formation is the thermal injection. So in this case, if hydrates are forming inside the tubing of flow lines, so heat is required to provide so that those hydrate plug can be melted from outside, and once become those melts, so it is then possible to create movement of those hydrates so that they can be removed from the flow lines. And for hydrate mitigation in the thermal method, in case of formation inside the reservoir, it is required to increase the temperature of the reservoir to destabilize the gas hydrate. So thermal heating alone is inefficient and expensive means of producing gas hydrates for long time because of limitation of the heating process. Sometimes it may happen that 75% of the heat applied for hydrate mitigation purposes may be wasted to non-hydrate strata. So this limitation makes the process inexpensive. Third method is the chemical injection method. In this method, methanol can be delivered to dissociate the hydrate, and certain chemicals and alcohols have capability to shift the pressure and temperature for hydrate dissociation. These are methanol, monoethylene glycol, diethylene glycol. Coil tipping is the method. If those prevention methods does not perform, in such cases, suppose hydrates or any blocking or deposits have taken place inside the tubing, so they can be removed physically by applying coil tubing operations. So it's a part of physical remediation process that can be carried out from inside of the well. Coil tubing effective lengths increasing within the industry, capable of 1 to 5 miles depending on the application or geography. So in the previous session, already working out this coil tubing has been explained. So through running of coil tubing inside the well, and by pumping hot oil or steam, the deposits can be melted and they can be removed from inside of the tubing. Another solid deposition issue is the paraffin deposition. Like hydrate formation, This paraffin deposition is also a function of temperature and pressure. Both temperature and pressure plays a significant role in the formation of paraffin deposit inside the formation, inside the well, inside any part of the processing equipment. So paraffin solubility is, is lost with decreasing temperature. So usually what happens, the downhole reservoir temperature is higher, uh, uh, remains high when well fluid starts flowing from the reservoir through the tubing. So temperature is lost when it flows across the entire well of different depths. Temperature is continuously lost, and because of significant amount of temperature loss, the paraffin solubility, which were originally in solution of the crude oil, this paraffin solubility is disturbed, and because of that, paraffin deposition takes place. So paraffin deposition is the matter of cooling effect developed inside the reservoir, inside the well system. So heat radiation during oil flow from bottom to surface of the tubing is one of the cause of paraffin deposition, and also when the fluids flows from the reservoir to the well, this expansion of oil and associated gases takes place, and it becomes a cause of temperature loss, and paraffin deposition may take place. Usually, in case of gas lifting process, since temperature of gas is very low, therefore it helps in the paraffin deposition issue, occurrence of the paraffin deposition issue, or whenever high gas oil issue is producing from a well, it means that if amount of gas producing from a well is higher than the amount of oil producing or flowing together from the well. In such cases, there is maximum chances of having deposition of paraffin. So if the temperature of crude oil reaches its cloud point, the paraffin will start precipitating and it will begin to congeal. Whenever further temperature drop takes place and continues, and it will reach the floor point, and it is the moment when crude oil will finally start flowing. Therefore, it is required to maintain both the cloud point and floor point at high level. Pressure is the another reason for paraffin deposition. So more is the pressure, more will be the cooling effect of crude oil, which normally takes place at the formation phase. As we know that for the well fluid to flow from the reservoir to the well, then from the bottom of the tubing to the top of the tubing, then from top of the tubing throughout the downstream flow lines, pressure differential is required. Without pressure differential, crude oil well fluid cannot flow from the reservoir to the bottom of the tubing, or cannot flow further through the well. Therefore, a pressure differential plays a significant role in the movement of the well fluid, but the same reason sometimes becomes the cause of paraffin deposition if higher pressure drawdown takes place. Pressure drawdown is nothing but the difference between pressure from one point to another when this flows from one section to another section. So expansion of gas occurs followed by evaporation of the lighter components as the oil leaves the formation and enters the wellbore. So in paraffin deposition issue, it becomes more significant in case of older oil fields, because in older oil fields, as we know that paraffins are mostly in solution of the lighter components, but the lighter components escape from the oil whenever pressure depletion takes place, and therefore the paraffin will be in situation with the crude oil. And in case of older oil fields, the deposition becomes severe because of this single reason. There is another reason for paraffin deposition, that is the presence of formation fines. So sand and shale, which act as nuclei for the cohesion of small waxy particles suspended in the oil. And this makes the wax particle larger and tends to separate more easily from the oil. So these are three important factors that lead to the deposition of paraffin. How to remove these paraffin deposits from the inside of the well or inside of deposition sites? So paraffin deposition methods are of three types: mechanical methods, chemical methods, thermal methods. In case of mechanical methods, physical removal of paraffin is done. by using different scrapers, cutters. They are inserted into the tubing for removal, and in some artificially processed like a surface system, scrapers are already attached in the rods, and they when during the movement or reciprocating movement of the rod pumps, the scrapers scrapes the paraffin deposits from inside of the tubing. And sometimes soluble and insoluble plaques are run through the flow line system in order to remove physically the deposits of paraffin. Another method is the chemical method. Chemical method works using solvents and dispersants. There are different solvents. Those are used in oil industry in order to dissolve the paraffin deposits and to remove the deposits from the well. So these are carbon tetrachloride, carbon disulfide, condensate, kerosene. These are the list of the solvents along with the dispersants, and dispersants are mainly made of water, and this dispersants is capable of removing 50 times as much as paraffin as the base solvents, and surface lines can be cleaned of paraffin by circulating these dispersions. Use of heat or is another method to remove paraffin. As you have seen the application of coil tubing operations. In coil tubing operations, what is required to inject hot oiling of hot water or steam is injected through coil tubing into the inside of the tubing. So this will raise the temperature of the well, and as a result of that, it will melt the deposits and they can be removed from inside of the well. Another inhibition methods of paraffin saw use of crystal modifiers, plastic coatings, surfactants as deposition inhibitors, rotamol heaters, magnetic fluid conditioners, reaction techniques to reduce deposition, field indirect heaters, microorganisms. So all these methods are applied in oil fields in order to contain the issue of paraffin deposition. In case of crystal modifier, paraffin crystals which will come out as single crystals whenever they first start to building up. So this paraffin will agglomerate if they find a nucleus that will help support in the agglomeration process. And this like here you can see here waxy crystals, single waxy crystals, they are agglomerating because they are getting a nucleus, and this agglomeration process finally build up depositions on cold surfaces. So this building network has to be damaged by adding crystal modifier. So polymers, copolymers, they work as paraffin crystal modifiers that can reduce the deposition of paraffin in wells. So in addition to the inhibition of paraffin deposition, many of them also can lower the cloud point of the crude. So this method suitably work in the prevention of paraffin depositions. Another preventing method of paraffin deposition is the use of plastic coating pipes. So plastic coated pipes can reduce the deposition rate initially, but once a layer of deposition takes place on the plastic coating pipe itself, thereafter further prevention of deposition rate becomes difficult. Surfactants may be used to contain the paraffin deposits. So it can surfactant can water weight the pipe surfaces. It acts as a barrier to prevent paraffin deposits, because whenever surfactant are added, it creates a water weight condition on the pipe wall. Therefore, paraffin deposition do not get the chance to directly come in contact with the surface of the pipe. However, if a well produces large volume of fluid, surfactants are not required, because whenever well produces significant amount of water along with oil, the temperature of the well fluid will be already high. Therefore, it will prevent the formation of the deposits in the well. Butane heaters are also used in order to contain the paraffin deposition. So butane heaters can raise the crude oil temperature because the paraffin deposition is nothing but this is the effect of temperature. And if the temperature of the crude oil is increases, it will melt the deposits and it can be removed. The oil temperature should be sufficiently high that it will not cool as to its cloud point before reaching the surface. So steam operation can be done. Steaming can be done in order to raise the temperature of the reservoir so that the increased temperature can be able to maintain the fluid flow from the reservoir to the well and to reach the surface facilities. So bottom heater system is an oil production tubing heating system that provides maintenance-free ongoing solution to many downhole issues. Fluid temperatures are maintained above critical flow point, thus preventing paraffin deposition in the tubing and decreases pressure drop. Magnetic fluid conditioners. This is one of the options nowadays, which is very widely getting recognition to contain this paraffin deposit. Magnetic fluid conditioners work in diverse and severe conditions, and this is also effective at a depth above the cloud point temperature, and they do not affect the crystallization temperature. What they do, they alter the crystal growth pattern, thereby reducing the severity of wax depositions, because the formation of the crystals and their growth is prevented by applying a magnetic field. Therefore, this can be removed. So production techniques can also be applied to reduce deposition if production rate is high, and that can be made that can be uh, maintained at high pressure only when pressure maintenance is done above boiling pressure. If a production rate is high enough to maintain flowing temperature above the cloud point of the crude, deposition of paraffin will not occur. In addition, higher flow rates help precipitated wax from adhering to a metal surface because of the shearing action of the wax particle at the deposition surface. Certain proofs have shown increasing deposition rates when the flow was in the laminar region. Indoor heaters may be applied as well in order to contain the issue of paraffin deposition, like water bath type gas fired heaters can be installed along flow lines and okay, along flow lines to maintain the temperature high enough to prevent gelling of high point crude. And lastly, the microorganisms can also be used to contain these paraffin depositions. So these are the kind of deposits which may develop based on the flow condition of the oil system, and they may give some hindrances in the fluid flow. Let me check some questions. So during the intervention to remove scale, paraffin, etc., how can we make sure in the field that the applied remedial action did not harm the reservoir? So this will be depending on the type of method we are using, and before applying any method, lots of laboratory works are also done. And if we use the kind of methods that does not have the potential to damage the formation, uh, then those methods are mostly applicable. So mechanical methods are the kind of preferred methods because they do not usually damage a formation. But whenever it is required to use chemical methods with time, they may result some deposition issues. Therefore, we have to be very careful in selection process of different solvents or chemicals. So these were the things I wanted to share in nutshell. And thank you for listening. I have presented this discussion because As I can say, most of the participants are from non-petroleum engineering background, and therefore I felt that it is my duty to introduce them about the oil well production system. So as I mentioned, the oil well production system, uh, they they uses different oil recovery methods. These oil recovery methods, starting from primary, secondary, tertiary, that will depend on the type of fluid present in the downhole, type of pressure conditions, and whether the primary and secondary recovery methods are able to work on those existing conditions or not. We accordingly we have to shift the methods of production from primary to secondary, then secondary to tertiary. Nowadays, we can apply any method together with the primary recovery methods. So, if any more questions, so if no more questions, I would like to thank all of you uh, for your patient listening and for extending your wholehearted support beginning from the first day of this FDP till this moment. Thank you all for joining this FDP also. Thanks a lot.
Thank you, Dr. Dhrubajyoti Neog, sir, for such an informative lecture on the topic flow assurance in the oil production system. It was indeed an informative session for all of us. As we have reached the end of this session, before ending, finally, I would like to thank all the attendees for coming to the session and making it a successful one.